everyone. In this session, we will learn about strings in Python. Let us begin by creating strings in Python. In the first example, we create a string using single quotes. Next, we create the same string using double quotes. Functionally, both are identical. Python does not treat them differently. The choice depends on convenience and readability. Then we use triple quotes to create a multi-line string. This allows text to span multiple lines while preserving formatting. Multi-line strings are especially used for documentation, long messages, or structured output. When we print these values, notice how Python preserves line breaks exactly as written. Now let's explore one of the most important properties of strings, immutability. Once a string is created, it cannot be modified. In the code shown, we attempt to change the first character of the string, hello. Python immediately raises a type error. This is not a limitation, it is a design decision. Instead of modifying the string, we create a new one by combining parts of the original string. The original value remains unchanged. This behavior makes string operations safer and more predictable, especially when working with data pipelines. Strings are ordered sequences, which means every character has a position known as an index. Indexing starts at 0 from the left. The first character has index 0. Printing word of 0 gives H. Python also supports negative indexing. Here, -1 refers to the last character. When we access characters using both positive and negative indices, Python returns the corresponding character instantly. This ability is fundamental for slicing, pattern matching, and text analysis. Python expects index values to be within range. If we try to access a position that does not exist, Python raises an error. In real programs, we avoid this by checking the string length before accessing an index. The simple habit prevents runtime failures and improves code reliability. We are here checking if the length of name is greater than 10. If yes, it prints the 11th character saved in name. L, it gives index out of range. Indexing gives us one character. Slicing gives us many. Slicing extracts a portion of the string using a start and end index. The end index is always excluded. When we slice from index 2 to 5, Python returns only the character in that range. Slicing never modifies the original string. It always creates a new one. Here, B of 2:5 gives LLO. This is immutability in action again. Python allows slicing shortcuts for cleaner codes. If we omit the start index, slicing begins from the start of the string. B of 5 gives hello. If we omit the end index, slicing continues to the end. B of 2: gives you LLO space world exclamatory. These shortcuts are widely used when extracting prefixes, suffixes, or partial values. They improve readability and reduce errors. Negative slicing is especially powerful. Here, Python counts characters from the end of the string. This is useful when the relevant information appears at the end, such as file extensions or identifiers. Printing text of -6 : will give you world exclamatory. The result is precise, readable, and efficient. Because strings are immutable, we build new strings using operators. The plus operator joins strings together. This is called concatenation. The message containing greetings plus within quotes plus name gives you hello space world. The asterisk operator repeats a string multiple times. Hello stored in repeat gets repeated 3 times as 3 is given after asterisk. These operations are commonly used for formatting messages, generating output, and creating patterns. Python provides many built-in methods for transforming text. Using sentence dot upper of converts text to uppercase. Using sentence dot lower of converts it to lowercase. The sentence dot strip off method removes unwanted space from the beginning and end of a string. This is essential when handling user input. The sentence dot replace of method substitutes J value for H and gives Jello world. Each method returns a new string. The original remains unchanged. The data dot split off method breaks the string Python, data, AI, ML into a list. We specify a delimiter and Python separates the string accordingly. Here the delimiter is comma. This operation is central to data cleaning, CSV processing, and log analysis. Sometimes we need to check what a string contains. Method like is alphabetic of or is alpha of, is digit of, and is all num helps validate input. Case checking methods is upper of, is lower of, confirm whether the text is uppercase or lowercase. The answers are always Boolean, true and false. These checks are essential for enforcing data quality. Python allows us to search within the string. Python is powerful and Python is popular stored in sentence. We can count how many times a word appears using sentence.countof. We can find the position of a substring using sentence.findof. We can check how a string begins or ends using sentence.starts with and sentence.ends with. These methods are widely used in validation rules and text analytics. Now we move to one of the Python's most powerful feature, f-strings. Python does not allow direct concatenation of strings and numbers. Doing so results in an error. F-strings solve this elegantly. By prefixing a string with the letter F, we can embed variables directly inside text. Name, storing Ajita, and age 35 is embedded in the text. My name is and I am dash years old. This makes code cleaner, safer, and easier to read. F-strings are not limited to variables. They can evaluate expressions directly inside the string. This allows us to perform calculations in line, reducing unnecessary code by multiplying price and quantity. F-strings also support formatting. Here, we control how many decimal places are displayed. By specifying value dot 2f, we are specifying only 2 decimal points should be there. This is especially useful in financial data, measurements, and analytics reporting. We can even call string methods inside f-strings. This allows us to transform values at the moment of display. It keeps the code compact and expressive. Some characters have special meaning in Python. Quotation marks, backslashes, and new lines must be handled carefully. Escape characters allow us to include them safely inside strings. This ensures correct syntax and accurate output. Here, the string EC is enclosed in double quotes. Inside the string, the word EC is also intended to appear within double quoted marks. Normally, Python would treat the inner quote as the end of the string, which would result in a syntax error. To avoid this, the backslash is placed before each inner double quote. Backslash tells Python this quotation mark is part of the text, not the end of the string. As a result, the string stored in quote becomes Python is easy to learn. In file paths, which is common in Windows systems, we must escape it using another backslash. Double backslash means insert a single backslash character in the string. So although we type double backslash in the code, Python stores and displays it as single slash. The actual value of the path becomes c:/user/python/documents. The escape sequences also helps format output. In Python, the backslash has a special meaning. It introduces escape sequence such as \n specifies new line, \t specifies tab. New line improves readability, tab aligns content neatly. These are commonly used in reports and console outputs. We can clean user input by removing spaces and standardizing the case. This is a common pre-processing step in analytics and machine learning. Then we can extract a file extension from a file name. This pattern appears frequently in automation and system scripts. Finally, we can also revisit the essentials: string creation, indexing, slicing, concatenation, repetition, and formatting. Mastering these operations gives us confidence and control over text data. Strings are not just data types. They are the backbone of real-world Python programming. The practice exercise sheets are attached in the link below. Practice it for better understanding. Thank you.